Have you ever just stopped and wondered what really happens when you type a prompt into an AI? It feels like magic, but it's actually this incredible journey. So today, we're going to follow your words right from your screen, deep into the mind of the machine, and see how it all works. Right? You type something, you hit enter, your words just disappear. And then, a few seconds later, this perfectly crafted response appears. But what is going on inside that black box? Let's trace the path and find out exactly what happens step by step.
So think of your prompt as a traveler, and we're about to follow it on this pretty wild trip.
Now, this whole journey, this entire process, it's all made possible because of one really revolutionary idea, something called the transformer architecture. This thing is the engine that powers basically every single large language model you've ever used.
Okay, so the very first stop on our journey is translation. Here's the thing. A machine doesn't get words like cat or sky. It doesn't speak English. It speaks math. It only understands numbers. So the first thing we have to do is translate our language into its language.
And that translation kicks off with a process called tokenization. This is where the model takes your sentence and just chops it up into smaller, more manageable pieces called tokens. Now, this could be whole words, sure, but sometimes a longer word, like language, might get split into lan and gauge. It's kind of like creating a little vocabulary list for the machine to work with.
Okay, once we've got our tokens, this is where the magic really starts. Each one gets turned into what's called an embedding. And really, that's just a fancy way of saying a long list of numbers, or a vector. But these numbers aren't random at all. They're calculated in a very specific way to capture the meaning of a word. So words that mean similar things like king and queen, they actually end up with similar patterns of numbers. This is the AI's first real step toward understanding relationships.
So, our words are numbers now. But a sentence is way more than just a jumble of words, right? It's the order, the relationships, that's where the meaning is. So let's get to the next stage and see how the model figures out that all-important context.
This is all thanks to something called the attention mechanism, and honestly, this is the heart of the transformer. It's the big idea. Instead of just reading words one by one, left to right, attention lets the model see the entire sentence all at once and figure out which words are most important to which other words.
So for a simple sentence like the cat sat on the mat, the attention mechanism is what helps the model go, aha, cat and sat are super connected and sat and mat are also connected. It's basically building a little map of relationships inside the sentence, which is the foundation for any real understanding.
But it doesn't just stop there. The model doesn't just do this one time. It actually stacks these attention layers one on top of the other. So the first layer might get a basic idea of the context. The next one refines it a bit. The one after that finds even deeper, more subtle connections. It's kind of like reading a complicated paragraph a few times over. Each time you get a much richer, more sophisticated understanding of what's going on.
So that raises a big question. How did the model get so smart in the first place? I mean, it wasn't just born knowing all this stuff. It had to go through this incredibly intense training process, like a huge global apprenticeship. To train it, researchers basically fed the model a massive chunk of the internet. We're talking about books, articles, websites, everything. And its goal, its one job, was deceptively simple. Just predict the next word in a sentence. But by doing that billions and billions of times, it was forced to learn so much more than just words. To get the next word right consistently, it had to figure out the patterns of grammar, of facts, of logic, and even stylistic things.
And when we say large language model, we really, really mean it. These models have billions of what are called parameters. You can just think of them as billions of tiny little knobs or dials. And during training, every time the model gets a word right, all of these knobs get tuned just a tiny, tiny bit. And over time, each one ends up capturing a little piece of the massive pattern of human language.
So, the model's been trained, it's analyzed our prompt. Now for the grand finale, the last stage of the journey. How does it actually create the response that we see on our screen?
Well, this part of the process is called inference, and what's so crucial to understand is that the model doesn't just write the whole answer at once. It predicts the single most likely next token, adds that to the sentence, and then uses that new longer sentence to predict the next token after that. It's literally building the entire response one single brick at a time, all based on what it thinks is most probable.
And this, right here, is why the size of the model is so incredibly important. You might be wondering, why do we need billions of those little knobs just to guess the next word? Well, the answer comes down to something researchers call scaling laws.
It turns out there's a pretty direct relationship here. The more parameters a model has, the more of those tiny knobs it can tune, the better it gets at seeing and understanding really complex and subtle patterns. So, a bigger model doesn't just know more trivia, it actually develops a more nuanced grasp of the relationships between ideas. And that's what leads to those really coherent and sophisticated answers.
So at the end of the day, if we strip everything else away, what is a large language model? It's a supremely powerful, expert-level pattern matching engine. It takes the pattern in your prompt, understands it, and then generates a new pattern, the response, by predicting the most probable sequence of words it learned from all that training.
And, while that brings us to our final, and maybe most fascinating question. We've seen the mechanics, right? The tokens, the attention, the probabilities. But if it's all just an unbelievably complex system for predicting the next word, where does genuine understanding actually begin? That's definitely something to think about.